Welcome to the future of enterprise decision making. In the next few minutes, you won't just see a concept, you'll witness a live, fully integrated AI ecosystem in action. This is what a secure, scalable, and robust intelligence platform actually looks like. Let's get started.
Drop a generic AI chatbot into a corporate network, and you quickly discover its blind spots. It guesses at financials, bleeds sensitive data across departments, and silently racks up massive cloud API bills when it gets confused. The sovereign GenBI platform resolves these liabilities by stripping away the standard chat wrapper. Instead, it operates as a secure multi-agent ecosystem, an autonomous decision engine built specifically for enterprise logic. This architectural diagram shows exactly how the platform is structured. We have three distinct zones. On the left, Pipeline A handles data ingestion, the center houses the multi-agent intelligence hub, and on the right, the vault enforces strict security and governance. A deterministic engine is entirely dependent on the quality of its inputs. If we want mathematical accuracy at the end of the line, we have to perfectly structure the raw chaos at the very beginning. Traditional data engineering pipelines are rigid. They break the moment someone uploads a messy PDF invoice or a non-standard CSV file. Yet in the real world, that is exactly the kind of unstructured data businesses run on. We solve this using agentic ETL. Instead of brittle code, AI dynamically reads and categorizes unstructured documents. It extracts critical metadata, like vendor names, total amounts, and expiry dates, instantly mapping variables into structured parent and child tables within Microsoft Fabric. Converting physical text documents into strictly defined, queryable SQL rows is a mandatory prerequisite. When the AI has hard numbers in designated columns to search, it doesn't have to guess. With the unstructured files fully mapped into the database, the data moves into the intelligence hub, transitioning from preparation into active analytical reasoning. This schematic highlights the chief orchestrator at the center of the hub. We don't ask one massive, monolithic AI model to know everything about the business. Instead, this core acts as a highly efficient traffic controller. When a user submits a complex, cross-departmental question, the orchestrator intercepts it. It immediately checks a vector cache to analyze the semantic intent of the request. It then splits the user's query into logical fragments. Those fragments are dispatched in parallel to isolated, highly specialized domain agents, like legal, marketing, or HR, ensuring each part of the question is handled by a dedicated expert. Specialized delegation is highly efficient, but domain expertise alone doesn't guarantee factual accuracy. For that, the execution engine has to stop predicting text and start pulling real database rows. Our domain agents are strictly forbidden from guessing answers. Their primary instruction is to translate the user's natural language into perfectly optimized Microsoft Fabric T-SQL code. We call this the zero hallucination RAG-to-SQL architecture. The agents pull verified database schemas to write queries that fetch exact mathematical values directly from the warehouse. To ensure absolute consistency, the system relies on golden queries, pre-approved historical SQL snippets injected directly into the prompt to serve as a mathematically deterministic template. Looking at the bottom right of the architecture view, we see the dual-mode intelligence layer. The system dynamically toggles between two different model tiers to handle these translations. We reserve frontier cloud models like GPT-4o for complex multivariable synthesis. For fast single-domain SQL generation, we route the task to a locally hosted small language model like 5.4, maximizing analytical power while avoiding runaway API costs. Unchecked AI execution is a massive liability. If an AI can write database queries, it must be forced to operate within strict enterprise data governance boundaries. This shield represents our zero-trust RBAC layer. There are no vulnerable, hard-coded database credentials passing through the engine. The AI authenticates natively via Microsoft Entra ID managed identities. This enforces physical lockouts at the database level. If a marketing agent attempts to execute a query against HR salary schemas, the Entra ID permissions simply reject the fetch. The AI cannot reveal what it cannot access. Combining this strict access control with a built-in telemetry engine means every single token spent and every millisecond of latency is silently logged, delivering a completely transparent, auditable FinOps environment. But the end user doesn't see any of this complex backend infrastructure. From their perspective, the experience is completely frictionless. Complex cross-departmental reporting that used to require 3 days of manual data aggregation is now executed flawlessly in 4 seconds. Once the raw database insights are fetched, they are instantly exported into polished, compliance-ready physical documents, completely eliminating manual copy-paste formatting errors. By combining agentic ETL at the front door, multi-agent orchestration in the core brain, and strict zero-trust execution at the database level, the sovereign GenBI platform graduates an organization from testing chat wrappers to deploying a true
Thanks for
autonomous
watching.
decision engine.
Feel free to drop us a comment, and we will be happy to help you out with your AI journey. Good luck.